On page 134, so this was our summary kind of picture showing the various hormones released by the adenohypophysis. So far, we have spoken of thyrotropic hormone, or TSH, affecting the thyroid, adrenocorticotropic hormone affecting the release of cortisol and other glucocorticoid steroids from the adrenal cortex. Now I want to look at the two gonadotropic hormones, follicle stimulating hormone, FSH, and luteinizing hormone, known as LH. Now, we actually first talked about these two gonadotropic hormones back in section C, when we were learning the menstrual cycle, as in the broader context of how a woman's body temperature changes between the first 2 weeks of the menstrual cycle and the next 2 weeks, and the release of progesterone. I want to remind you of the menstrual cycle. On page 132b, do you remember this chart? Okay, this chart, and you probably had a lot of extra notes on it, goes back to section C. And that's where we described it. But let's just summarize it. We are reminded that in women, the pituitary gland releases FSH and LH beginning at puberty. And but it releases these two hormones cyclically, alternately. It releases FSH for 2 weeks, and then it switches to LH for the next 2 weeks. FSH, follicle stimulating hormone, does exactly what its name says. It stimulates the growth of an ovarian follicle in the ovary. And we talked all about that back in section C. And not only does FSH cause an ovarian follicle to grow, but it causes the follicle cells to secrete estrogen. And estrogen, of course, is the feminizing hormone, and it does cause some thickening, not a lot, but some thickening of the endometrial lining of the uterus. Beginning approximately on day 14, the pituitary switches and starts releasing LH. The first thing that luteinizing hormone, or LH, does is it causes ovulation. It causes the egg to pop out of the ovary and enter the fallopian tube. So now a woman can get pregnant. The LH continues to be secreted for another 2 weeks, for the 2 weeks after ovulation, approximately, and it stimulates the corpus luteum, which is the name we give to the follicle cells after the egg pops out. Instead of calling it an ovarian follicle, we call it a corpus luteum, and it causes these follicle cells to secrete progesterone and estrogen. Progesterone is the hormone that prepares a woman's body for pregnancy. And it causes growth of blood vessels in the endometrial lining. So there is significant thickening of the endometrial lining and growth of blood vessels as the womb, as the uterus, is being prepared for possible implantation by an embryo. Because the egg's been ovulated, a woman could get pregnant. And so now the womb will be all prepared in case she does get pregnant. Now, by approximately day 28, the pituitary stops releasing LH. This happens whether or not she gets pregnant. The pituitary stops releasing LH. Of course, we know that if she gets pregnant, there is a hormone that works like LH, that does what LH does, called Human Chorionic Gonadotropin, produced by the outer sac, the chorionic sac of the baby. So if she gets pregnant, the corpus luteum won't degenerate, even though LH is not being secreted by the pituitary. There's a hormone that mimics LH called human chorionic gonadotropin that will continue to stimulate the corpus luteum to continue to secrete progesterone for the duration of the pregnancy. But assuming she doesn't get pregnant, and there is no human chorionic gonadotropin, so the pituitary stops releasing LH, the corpus luteum degenerates, it stops secreting progesterone, and without progesterone, there's a shedding of the endometrial lining. That's called menstruation, and the cycle begins all over again. If she had gotten pregnant, then the human chorionic gonadotropin continues to stimulate the corpus luteum to secrete progesterone, and that kind of shuts off the pituitary, because basically it's still detecting progesterone levels, and so it just stops it from switching to FSH. So it basically, you stop any menstrual cycles during pregnancy. Now, assuming she didn't get pregnant, so the pituitary switches back to FSH, and we begin all over again. So let's summarize what we've just said by looking at a chart that is on page 133. So on page 133, all right, so here it says gonadotropic hormones, FSH and LH. Here they are, the two gonadotropic hormones, the two hormones that affect the reproductive organs. And here I've listed what they do in males. We'll address that after. But what do they do in females? FSH is released during the first 2 weeks, called the pre-ovulatory phase. It stimulates the development of ovarian follicles in the ovaries. And it stimulates the secretion of estrogen by the follicle cells of the ovaries. LH is secreted during the post-ovulatory phase. It stimulates ovulation, and it stimulates the production of progesterone and estrogen by the corpus luteum that is in the ovaries. Let's take a look at page 132D. 132D. Here's a hypothalamic neuron. The neuron is releasing a neurotransmitter releasing hormone, or RH. This particular one is called GnRH. It stands for Gonadotropin Releasing Hormone, because it's going to control the release of gonadotropins. You'd say, where is that written, GnRH, where that means Gonadotropin Releasing Hormone? The bottom of page 127. This is carried by the hypothalamic pituitary portal vein to the adenohypophysis. It causes some cells to release FSH and other cells to release LH. Now we know that FSH is actually going to be released for the first 2 weeks, and then LH will be released for the next 2 weeks. So it's released alternately, cyclically. Here is, look at that, I drew an ovary. Yes, I'm a great artist, and I wrote ovaries just so you know what it was. All right, and so we know that follicle stimulating hormone, FSH, stimulates the growth of an ovarian follicle and causes the follicle cells to secrete estrogen. LH causes ovulation, and it stimulates the follicle cells of the corpus luteum to secrete progesterone and estrogen, both. All right, so we've already, this was just like what we saw on page 130. What FSH causes, what LH causes. Now, this follows a negative feedback loop. A negative feedback loop. So we know that as FSH causes the ovaries to secrete estrogen, the estrogen hormone level rises in the bloodstream. And as the estrogen level in the bloodstream rises, that is circulating in the bloodstream, and that increasing estrogen level in the bloodstream inhibits these cells from releasing FSH. And it even inhibits up here in the hypothalamus. But let's just focus on here on the pituitary. So the higher the estrogen level in the blood, the more it inhibits further release of FSH. Does that follow? It's a negative feedback loop. Similarly, LH causes progesterone to be released. As more and more progesterone is secreted, the level of progesterone in the bloodstream rises higher and higher. Higher levels of progesterone circulating in the bloodstream inhibit cells of the adenohypophysis from releasing LH. So now, with that in mind, we can explain the whole concept of oral contraceptives or birth control pills. So if we return back to page 133, so on page 133, FSH increases estrogen secretion into the bloodstream, and the higher the estrogen level goes, it inhibits the release of FSH. LH causes the release of progesterone into the bloodstream, and the higher the progesterone level, it inhibits the release of any more LH, the negative feedback loop. So let's talk about birth control pills. Now, birth control pills, they come in these little cases. These birth control pills contain estrogen and progesterone. Now, if a woman starts taking estrogen, that estrogen, her estrogen levels in her bloodstream are going to rise, and that's going to inhibit her pituitary gland from releasing FSH. If her pituitary stops releasing FSH, then no ovarian follicles will develop. Does that follow? Because you're taking the estrogen, which inhibits the pituitary. That's what we just said. You take estrogen, and it inhibits the pituitary from releasing FSH. Now, if the birth control pill contains progesterone, and the woman starts taking progesterone, raising to the progesterone level in her bloodstream, that will inhibit the pituitary from releasing LH. So that means that she's not going to ovulate. Now, really, probably just taking either just estrogen or progesterone would be sufficient to prevent pregnancy. Because either, in one case, an ovarian follicle won't develop, or taking progesterone, you won't ovulate. But usually the birth control pills contain both to really make sure that a woman's not going to get pregnant. They're called oral contraceptives to prevent conception. All right, but it's a little bit more involved than that. Everybody got the basic idea. All right, so that's exactly what I wrote here. The estrogen in the pill inhibits the release of FSH. The progesterone in the pill inhibits the release of LH. In most of these formulations, those of you who might be familiar with these, they will commonly, first of all, they always have 28 pills. Because when women are taking birth control pills, they have perfect 28-day cycles. Sometimes, in fact, some women will take birth control pills not because they're taking them to prevent pregnancy, but because they have very irregular menstrual cycles, and this normalizes their cycle, makes it perfect. But you may have noticed that commonly the pills are in different colors. Now, there's different ways that they appear. In my example that I just kind of made up, so I show the first 7 pills white, and then the next pill's red, and then the next one's green. The ones that are white have nothing in them. There's no estrogen and there's no progesterone. They're essentially placebos. There's nothing in them. I'll come back to those in a moment. Those that are red have estrogen. Those that are green have progesterone and estrogen, both. Now, let's remember an important idea. If you take estrogen, yes, the estrogen is going to inhibit the pituitary gland from releasing FSH. That's what we just said. But does estrogen affect a woman's body? Isn't it a feminizing hormone? And won't it even cause some small thickening in her endometrial lining? So at the same time it's inhibiting her pituitary, it does affect her body. That's what estrogen does. So the first pill, these pills that are red contain estrogen. That's a feminizing hormone, and it causes some thickening in the endometrial lining. Okay, you get to around pill 14 or 15 or 16, it's got progesterone and estrogen, progesterone. Now, the progesterone is going to inhibit the pituitary gland from releasing LH. That's why she's taking it. But progesterone does stimulate thickening of the endometrial lining and the growth of blood vessels. It does affect the uterus. Of course it does. Whether it's progesterone produced by a woman's own ovaries or whether she takes it in a pill. So this progesterone that she's now taking, at the same time it's inhibiting her pituitary gland, it is causing significant thickening of the endometrial lining of her womb and the growth of blood vessels. Is everybody okay on that? Now she finishes pill number 28, which had progesterone in it, and she buys a new little kit at the drugstore, and she takes from the new little kit case pill number 1. What's in pill number 1? Nothing. What's in pill number 2? Nothing. So all of a sudden, what's happened to her estrogen and progesterone hormone levels? They drop. And when progesterone stops being secreted, doesn't it cause shedding of the endometrial lining? So when she's taking these pills, which have nothing in them, that results in menstruation. That results in having a period. So, because the question you should have been thinking all along is, if a woman's taking these pills, why does she still seem to have a normal menstrual cycle and a normal period? That's because when she's not taking anything with an estrogen or progesterone in it, that's when her endometrial lining is shed. So you'll notice it is mimicking or simulating a perfect menstrual cycle. First, there's essentially not much of any hormone. Then there's increasing levels of estrogen. Then there's increasing levels of progesterone and estrogen. And then nothing. And so the estrogen is going to cause some thickening of the endometrial lining. The progesterone cause major thickening and growth of blood vessels. And when she's taking nothing, she sheds the endometrial lining. So at the same time that it's inhibiting her pituitary gland from releasing FSH and LH, so her own ovaries are not doing anything. Her own ovaries are not being stimulated to do anything. But the estrogen and progesterone are affecting her uterus, her womb. Does everybody follow that? Now, commonly when women have been taking birth control pills for a while, so when they stop taking them, sometimes, not in every woman, but sometimes, basically it takes a while for a woman's menstrual cycle to start up again, because her pituitary gland has been inhibited for so many months by taking estrogen or progesterone. It's been inhibiting her pituitary from releasing FSH and LH, that it may take a few weeks, a couple of months, for it to jumpstart or get back into gear again and start releasing FSH and LH in this alternate pattern. This is a product, it goes under, one of the brand names is Yasmin. The pharmacologic category is a contraceptive. It's got estrogen and progestin, that's what they call progesterone, and it's used to prevent pregnancy and also treatment of premenstrual dysphoric disorder. Towards the bottom, adverse effects. One of the adverse effects you'll notice is a slight increased risk of arterial thromboembolism. And this is also the problem of why many gynecologists are reluctant to prescribe essentially estrogen in postmenopausal women. When a woman reaches menopause, what happens, interestingly, at menopause is that the ovaries stop working. Interestingly, the pituitary gland still is releasing FSH and LH, but the ovaries stop responding to the FSH and LH. So in fact, postmenopausal women have very high FSH and LH levels because there's no negative feedback. There's no release of estrogen or progesterone to inhibit the pituitary from releasing FSH and LH. If you look on the next page, it indicates what, at least with this particular brand, what do you do if you forget to take a pill? And if you miss one, if you forget to take it once, or if you forget to take it twice. If we look at the mechanism of action, so it describes exactly what we've been talking about. What do these oral contraceptives containing estrogen and progesterone do? They inhibit ovulation by a negative feedback mechanism on the hypothalamus, which alters the normal pattern of gonadotropin, that means FSH and LH secretion, of follicle stimulating hormone and luteinizing hormone by the anterior pituitary. So back on page 133. So on page 133, FSH and LH, what do they do in males? In males. Now, first off, I want to remind you that in guys, the pituitary gland releases both FSH and LH simultaneously. It's not like it alternates as it does in women. Remember, in women, FSH for 2 weeks, then LH for 2 weeks. In guys, beginning at puberty, they release FSH and LH. Notice also that FSH and LH, while these hormones are produced by the pituitary glands of both men and women, they're actually named for what they do in women, not named for what they do in men. But it is the same hormone. FSH in guys stimulates the production of sperm by the testes. That's called spermatogenesis. LH stimulates the production and secretion of testosterone, the male sex hormone, into the bloodstream by the testes. So both FSH and LH are affecting the testes constantly for a guy's entire life. Let's summarize this by looking at page 132C. So this is 132C. You'll notice this is entirely different from the previous picture. This has testes for the ball-shaped ring instead of ovaries. Here we have the hypothalamic neuron releasing gonadotropin releasing hormone. It's carried through the hypothalamic pituitary portal vein to the adenohypophysis. It stimulates the release of both FSH and LH, both at the same time. FSH causes the testes to produce sperm. LH causes the testes to produce and secrete testosterone, the male sex hormone, into the bloodstream. Now let's look at the negative feedback loop. As LH causes the testes to secrete more and more testosterone into the bloodstream, the testosterone level in the bloodstream rises, and that inhibits the pituitary from releasing LH. That is a negative feedback loop. The problem is there's no negative feedback loop here. When FSH causes the testes to produce sperm, do sperm go into the bloodstream of a guy and inhibit his pituitary gland? No, sperm come out of the penis. There really isn't a negative feedback loop to inhibit the release of FSH and thereby inhibit sperm production. This is why there is not a male birth control pill. They have proposed a chemical called Inhibin. And your book mentions Inhibin. So in theory, the testes are supposed to produce this chemical called Inhibin that will feed back to the pituitary and inhibit the release of FSH. It just hasn't worked yet. In summarizing this, the way that the birth control pills for a woman worked, remember, they contained estrogen, which inhibited the release of FSH, and they contained progesterone, which inhibited her pituitary from releasing LH. So it shut off the release of FSH and LH, so there was no stimulation of a woman's ovaries to do anything, to produce eggs, to secrete hormones or anything. But if you give a guy testosterone, let's give a guy a lot of testosterone, let's see what's going to happen. And this isn't going to work. Giving him a lot of testosterone may inhibit the release of LH, so his own testes won't produce testosterone, but that's not going to stop the production of sperm. What we want is to, in a male birth control pill, is to stop the production of sperm. We don't want to stop the production of testosterone. Because frankly, if the guy doesn't have enough testosterone, he won't care about having sex. So you want him to have sex, but not produce sperm, so that way he can't cause impregnation. Does everybody follow that? So we just don't have one yet. That doesn't mean we won't, but based on what we know so far, it's not sufficient to figure out how to turn off the sperm production. Let's summarize what we've been learning about on page 134b. So 134b, it says follicle stimulating hormone and luteinizing hormone. What does FSH come from? The adenohypophysis. What does it do in males? It stimulates sperm production. What does it do in females? It stimulates growth of an ovarian follicle and estrogen secretion. What causes the release of FSH? GnRH from the hypothalamus. And what would inhibit the release of FSH? In males, I don't know, maybe Inhibin. I put it in brackets, don't know, I'm not going to test you on it. Still theoretical, don't know, maybe it'll work, hasn't worked so far. In females, though, raising the estrogen level inhibits the release of FSH. Okay, what about LH? LH, released from the adenohypophysis. In males, what does it do? Stimulates production of testosterone. In females, stimulates ovulation and progesterone secretion. What causes the release of LH? GnRH from the hypothalamus. What will inhibit or reduce the release of LH in males? Raising testosterone levels inhibits LH. In females, raising progesterone levels inhibits LH. Now, since we're on this page, I'll just remind you about human chorionic gonadotropin. Human chorionic gonadotropin is actually produced by the chorionic villi of the placenta, the outer sac. It stimulates the follicle cells of the corpus luteum to secrete progesterone, which is exactly what LH does, so it mimics LH. And therefore, since the corpus luteum continues to secrete progesterone for the duration of the pregnancy, this maintains the thickness of the endometrial lining and the vascularization to nourish the embryo. What are the factors that cause the release of human chorionic gonadotropin? How about getting pregnant? That's what causes it. And that's what they test for, HCG, that's the pregnancy test. And what would stop the release of human chorionic gonadotropin? Termination of the pregnancy, since the source of it is the sac around the embryo.